Now, the last identity that we need to be able to prove is this one, and we haven't seen this one before, so take a moment now to pause the video and to write this down. Now, some people will want to look at this and just memorize it, and sure, you can probably do that just like learning lines of a play, just memorize how it goes. But that's not going to help you prove it. So if you've got to memorize this and prove it, you might as well memorize it in a way that makes good sense, so that then you're not having to memorize the actual N's and R's and C's every time. All you need to do is recall a story that sits in your mind. That will help you also to prove it. So here's the story. We order some pizza. There are 10 toppings that we can choose from. We're told that we can only choose 3. All right, how many different ways can we order our pizza? Well, if we're choosing 3 from 10, then there must be 10 choose 3 choices. And we know how to figure that out. We can do 10 factorial over 7 factorial times 3 factorial in our calculator, or we can just type 10 choose 3 into our calculator using the N choose R button. All right, what about another approach? Someone says to you, yeah, but do you want anchovies on your pizza? Why am I bringing this up? I'm making a story so that you'll remember this. You'll remember the anchovies. Why? Because just about everybody knows whether they like anchovies or not. The people who like them love them, and people who don't like them really don't like them. So they're quite divisive. So you're going to remember the anchovy on the pizza story here. Do you want anchovies? Well, if you do want anchovies, that's going to be one of your 3 choices, isn't it? So how many ways can you order the pizza with 3 toppings if one of the toppings you've already chosen? It's the anchovies. Well, you need 2 more toppings. Out of how many to choose from? Not 10, only 9. Right, so there's 9 choose 2 ways to get a pizza with 3 toppings that's got anchovies on it. All right, what if you don't like anchovies? All right, well, you're definitely not going to choose those then. So out of the 10 toppings, you're like, oh, not them. I'll just choose from these other 9, thank you. How many do you need to choose? 3. You haven't chosen any yet because you didn't want the anchovies. So there's 9 choose 3 ways that you can get your 3 toppings if you don't want anchovies. Now, whether you do want anchovies or you don't want anchovies, these 9 choose 2 orders of pizza and these 9 choose 3 are completely different sets, aren't they? There's no crossover. They either have anchovies on them or they don't. So if we add these together, then that should give us a good idea of how many choices there are, because either we have the anchovy ones or we don't. But we've already considered that there's 10 choose 3 ways to choose the pizza, whether we thought about anchovies and whether we wanted them or not, or we didn't think about anchovies at all. Obviously, it should be the same number of choices total. So we've proven there that 9 choose 2 plus 9 choose 3 must equal 10 choose 3. And so we've proven this here. 10 choose 3 must be equal to 9 choose 2 plus 9 choose 3. Now, remember the story of the anchovies on the pizza so that you can prove this, but you can also memorize it without having to remember the actual n-1s or the r-1s. You can think about actual numbers. And this will work no matter how many toppings you want to have on the pizza and how many you're meant to choose. Just pick anchovies and decide whether you want them or not and come up with your proof. Okay, now just for fun, let's prove this same identity algebraically. Because this is just a good way of practicing your unrolling and rolling up of factorials and just checking that you can actually do it. Now, when you're proving something, I always like to start with the left-hand side or the right-hand side and finish with the other. In this case, I'm going to choose to start with the right-hand side because I can see that there's something to do. Okay, and that's going to give me a way of starting with something messy and tidying it up until it looks like the left-hand side. So the right-hand side, in a proof, we need to make sure we don't do too much in our head because we're literally proving line by line without making any sudden jumps so that somebody can look at it and really see that we know what we're talking about. So here we've got, by definition, n minus 1 factorial over n minus 1 minus bracket r minus 1, all in brackets, factorial, r minus 1 factorial. Now, why did I not work that out in my head? Well, because it's a proof. And so I'm proving that I know I need to do this minus this. On the next line, I'll tidy that up. And this part here is going to be n minus 1 factorial on the top, and on the bottom we need to have n minus 1 minus r factorial, r factorial. Okay, so next thing to do, let's tidy it up. On the top we've got our n minus 1 factorial still, and getting the bottom a bit nicer, this will be n minus 1 minus r, but then the negative here and the negative here means this is plus 1. So the plus 1 and the minus 1 will cancel out, and this part will just be n minus r factorial, and then r minus 1 factorial. And then this part over here we can just leave as it was. And we get that. Now the logical thing to do next is to add my fractions by making common denominators. And if you look at the denominators now, you can see that they're not the same. But before you go ahead and multiply all 4 terms together to make a really nasty looking common denominator, let's just take a moment, because we can see that this and this are actually really similar. R factorial and r minus 1 factorial, that's just one unrolling of r factorial to get to this one, isn't it? So I can make them similar. And here I've got n minus 1 factorial, and this is, sorry, n minus r factorial, and this is n minus r minus 1 factorial. So this one is like that one that's just been unrolled once. So before I go any further with my common denominators, even though it looks like more work doing an extra line here, I think it's actually going to save me a bit of time. What I'm going to do is make them more similar. So this one I'm going to turn into that one plus a bit. So I've got n minus r without a factorial multiplied by n minus r minus 1 factorial. Now they're both going to have something that's the same. This one's got one little thing extra. And this one over here also was, hang on, I'll adjust each one as I go. So this one still had that. We'll call it n minus r minus 1 factorial. I've just rearranged the 2 terms there. Now if we compare these 2 bits, this one is like that one, unrolled once. So we'll change this one. We'll call it r, just r, not r factorial, multiplied by r minus 1 factorial. And this one can just stay as it was, r minus 1 factorial. Now, it looks more complicated, but it's going to be simpler on the next line, because now that we look at what common denominators they've both got this one. Hang on, I should use another colour to underline or highlight things. They've both got this, and they've both got this. And the only thing that's different on either of them is just the simple r and the n minus 1 r. So they're the bits that I'll need to multiply the tops by. So my big common denominator then is, I need the n minus r, I need the r, let's put that out the front because it's nice and simple, and then I need the 2 factorial sections, the complicated looking one and the r minus 1 factorial. All right, what have I multiplied this fraction by to get this? Just an r. So I've got to do the same to the top. So I've got r bracket n minus 1 factorial plus, what have I multiplied this whole fraction by, sorry, this denominator by to make this one? N minus r. So I need to do the same to the top. So I have n minus r, n minus 1 factorial. Now, do you notice anything about the 2 terms on our numerator? They've both got n minus 1 factorial in them, don't they? So continuing on here down the other side, I could factorize the top now and bring n minus 1 factorial out the front of some brackets. What's going to be left in the brackets is going to be our r plus our n minus r, which doesn't really need to be in brackets now. And you can see, I think, that we're going to have r minus r. That gets rid of our r's, really, doesn't it? I could just cross them out. And we end up just with an n there. And on the bottom, let's rewrite all of this. We've got r bracket n minus r. Then we've got our n minus r minus 1 factorial. And we've got our r minus 1 factorial. All right, what next? Well, it's interesting that I unrolled some of my factorials to make my common denominators, but now I can actually roll some of them back up again. You'll notice that on the top here I've got n multiplied by n minus 1 factorial. That simplifies up beautifully to just make n factorial on the top. And on the bottom, have a look at this term and this term. If you have r multiplied by r minus 1 factorial, what you've actually got is r factorial. And if you have n minus r multiplied by n minus r minus 1 factorial, then what you actually have is just n minus r factorial. So that actually tidies up beautifully just all in one step. And lo and behold, what we've actually got here is now the formula for the left-hand side. So just like that, we're finished.